Hi, 8th graders. So we're going to continue the Jack and Jill lesson about describing steepness, and we're going to connect that to something called the rate of change in this video. So activity 2.1, please follow along in your book. This is on page M2-25 in your book. So it says, on Monday, Jack and Jill walked from their home up a hill to get to the bus stop. They walked 4 yards every 3 seconds. So this 4 yards every 3 seconds, this is the rate that they are traveling. So this is their rate or their speed, you could think of it as. It says write an equation to represent the distance d Jack and Jill walked over time. So our equation is going to represent the distance. So we're going to use d equals, well, if this is the rate that they're walking at, this rate would be multiplied by the time that they walk. So 4 yards every 3 seconds, we'd write it as a fraction like that, times t. So here's the equation that represents the distance they walk over time. So the distance depends on the time that they walk. Does this situation represent a proportional relationship? Yes, it would, because it's in the form y equals some number times x. Yes, this does represent a proportional relationship because it is in the form y equals kx. Constant of proportionality is 4/3, because that's k. That's the number being multiplied by the independent variable, by x. In this case, it was t. Now we're going to work on completing this table, and I'm gonna do maybe one for you here, and then I'm gonna let you pause the video and work out the rest of the table. So it says complete the table, then graph the points, finally draw a line to represent the relationship between the time Jack and Jill walked and their distance from home. Let's start with the table. All right, let's not get ahead of ourselves. Let's complete the table. So time spent, distance. So this is the seconds that they spend walking. This is the distance they travel in yards. So obviously, if they travel 0 yards, they've spent 0 seconds walking. Now, for 1 second walking, lots of ways we could do this, but we already know that they are traveling at this rate. So let's write this as a ratio: 4 yards every 3 seconds. If I want to know how many yards they travel in 1 second, I could create a proportion using this ratio on one side, and then another ratio using 1 second in the same spot as I put the seconds in the first ratio. And then this becomes x. So then I would cross multiply 4 times 1, 3 times x. So 3 times x equals 4 times 1 is 4. And then I would solve this equation by dividing both sides by 3. And x would be 4/3 or 1 1/3. I'll just leave it as a fraction. So there's my distance in 1 second. I would use this same idea to fill out the rest of this table. So I want you to pause the video and come back and check answers. All right, let's check answers for the table. So 3 seconds, you should have found that was 4 yards. That was actually the rate they gave us. In how many seconds does it take them to travel 8 yards? You can use a proportion just like this. You should find that it was 6 seconds. For 7.5 seconds, again, you can use a proportion. You should have found that it was 10 yards. And after 9 seconds, you should have found it was 12. Please let me know if you need some help on identifying those blanks in that table. Now we're supposed to graph these points. So now we're going to put these points on a graph. So 0, 0, it's right there. 1 and 4/3, and we got to be careful with our units here. So 1 second, 4/3. So here's 1 second. 4/3 is 1 1/3, which is a little less than 1.5. So I'll put it about right there. 3 seconds, 4 yards. Right there. 6 seconds, 8 yards. Make sure I'm on the right spot here. I think so. 7.5 seconds, which is this line right in between the 7 and the 8, 10 yards. Right there. And then 9 seconds and 12 yards. So I'm up on this vertical line all the way to 12. Right there. And then it also says draw a line to represent the relationship. So those are just 1, 2, 3. That's 6 different specific examples. When we draw this line through it, this represents all the possible examples, all the possibilities of distance and time that are in the same ratio as they are walking. So now we're going to turn the page to page 26. What is the unit rate? And explain what that unit rate means. So let's look back at our table. Unit rate, yards per 1 second, which is actually right here in the table. So the unit rate is 4/3. 4/3 is the unit rate. And we want to tell what this represents. This is how far they walk per second. So the unit rate represents 4/3 yards per second, per 1 second. Number 5. So explain why Tanner's reasoning is incorrect, then explain why the graph goes up as you move from left to right. So Tanner says this graph goes up from left to right because Jack and Jill were walking up a hill. It actually does not have anything to do with walking up. The reason the graph goes up, let's look at it. The reason the graph goes up, so this is time that they spend walking. The vertical axis is the distance. So the reason it goes up is because the distance is increasing. So the graph increases in height to represent an increase in the distance they walk. So this would actually look the same as if they were walking on a flat path or even downhill. So the fact that they're walking up a hill is not why this goes up. It's the fact that their distance is increasing. All right, turn the page to page 27, and we're going to wrap up this activity. So the rate of change for a situation describes the amount that the dependent variable changes compared with the amount that the independent variable changes. Please highlight that. So rate of change. When we write the rate of change, it is always dependent over independent. Dependent variable over independent variable. In other words, y over x, similar to what we saw for constant of proportionality. So we're going to identify the independent and dependent variables in this situation. I think I already mentioned it. So we had distance and we had time. So we had yards and we had number of seconds. Think about which one depends on the other one, and that is the independent variable, or that is the dependent variable, sorry. So independent, there we go, variable, dependent variable. Hopefully you can recognize that the one that depends on the other is the distance. The distance depends on the time. So distance, this is the number of yards. The independent variable then is the time, which is the seconds. Okay. And I kind of talked through the reasoning. Dependent is the one that depends on the other one. Identify the rate of change. So rate of change, remember we said, is dependent over independent. So dependent over independent. Y over X. If we look back at our graph, look back at that table, we have lots of options. If we look back at the rate they gave us at the very beginning, it was 4 yards, which is the dependent, over 3 seconds. So the rate of change here is 4 over 3. Consider the rate of change. So this was 4/3. Constant of proportionality, back when we wrote our equation, back on page 25, we said the constant of proportionality was 4/3 in that equation. The unit rate was also 4/3 in this situation. We identified the unit rate in number 4 on page 26. So what do you notice about all of these? The constant of proportionality, the rate of change, and the unit rate are all the same. How would the rate of change and the graph of the relationship change if Jack and Jill walked faster? So if they walk faster, think about what happens. I want you to write your response to that. If they walk faster, the rate of change will increase and the steepness of the graph will also increase. If they walk slower, the rate of change will decrease and the steepness of the graph will also decrease. This is similar to the question we answered at the very end of our last lesson, where the greater the ratio, the greater the steepness of the line. Same thing, the greater the rate of change, the greater the steepness of the line. That wraps up activity 2.1. Make sure that you have all of that stuff copied. Feel free to go back and rewatch the video as needed. Hope you guys have a wonderful day.